In this demonstration, I want to show you the power of pressure. What I have here is an aluminum can with a small amount of water that's been heating up to the point where now it is boiling. You might be able to see the water vapor coming out, the steam, where the water has been boiling. So I know that it's incredibly hot inside this container. Now, watch what happens when I take this and invert it into a container of room temperature water. Woo-hoo. Oh, that was beautiful and nearly instantaneous. So what happened? Normally, with just an empty aluminum can, you have air inside and air outside that's at the same temperature. When that's the case, that means that the fluid that is the air has the same pressure inside and out as well. That pressure is atmospheric pressure, right? Same density, same pressure, everything's great. But as soon as I started heating up the water in the bottom of this can, the gas inside the can started to heat up as well. Now, because it's open on the top, the gas inside the can wanted to have the same pressure as atmospheric pressure outside. The only way for that to happen as the temperature built was for gas to escape. So you had fewer molecules. So you had fewer collisions imparting force on the edges of the can. That way, each of these more energetic collisions happen less often because there were fewer molecules of the gas. That allowed for there to be a higher temperature inside while the pressure inside and outside stayed the same. Now, as soon as I inverted this can in the water, a couple of things happened. First, I closed off the can from being, the gas inside the can from being exposed to the outside air. So now the pressure inside the can is kind of sealed off. The molecules can no longer freely enter or exit the can like they could previously. At the same time, the temperature inside started to cool. As soon as those air molecules inside the can started to cool down, they didn't have the same amount of energy, they didn't have the same amount of force in their collisions with the wall. So what happens? The pressure inside the can drops. So now we have another example of a pressure differential. You have atmospheric pressure pushing in on the can from all sides on the outside, but inside we now have less than atmospheric pressure. This means there is a net force that pushes in on the can, and clearly that net force is strong enough to crush the can rather effectively and quickly. That's the power of pressure.